was a quite new aspect of manipulation, underwater manipulation, that fascinating me. And that is this one. If you examine the projects that are being conducted in these manipulation topics underwater, they also use rigid structures and robots that are very, very big, heavy, and yes, the manipulators can reach a lot of a lot of areas. They can do a lot of tasks, but they are rigid, not flexible. So there is now a new trend, but it's still quite new. So there's not much work already done about this. To try to take the so-called soft robotics also underwater. This is not easy because soft robotics means robots that are on one hand they are made by soft materials that are flexible and can be deformable somehow. So it is easy to manipulate things because you can even grasp some object that is fragile without damaging it. So still, this kind of deformations and this kind of flexibility introduce a lot of uncertainty, a lot of unknown behaviors in your control systems. And so if on one side you have a more flexible system that can be more effective in manipulating, you have on the other side the control that is very, very complex. And this is done. There is a lot of research in air, so not in the water. Taking this research from air and put them into water, it's even more more difficult, more complex, because in water you have also a lot of disturbances from environment, because you have current, you have, for example, if you rely on vision to see the object that you manipulate, you have a lot of problems for the lighting conditions, because underwater usually the environment is dark, so you have to, for example, use artificial illumination, but still this puts some difficulties, some troubles on your cameras. So there's a lot to be studied and to be solved, a lot of problems to be solved. But still, this